All right, good morning. Hopefully you had a good reading week. Let's now get back to our normal learning. And we still got 15 more lectures for the semester. But I will give you a roadmap maybe a little bit later because we still need to finish some relatively straightforward topics before we get to inheritance, which will be sometime in November, early November. But I will definitely give you some look ahead before we get to inheritance. All right, so announcement. For your programming test 1, there has been slight delay on my end. Not the TA, but my end. So I will get it sorted as soon as I can. So I will definitely get back to you by the early or middle of next week. You will definitely get your marks and also get your feedback, for sure. Okay. And for lab number 2, it will be due on this Friday. Just don't forget. And you definitely want to spend as much time as you can afford on lab number 2. It's actually a very important lab for you to get right. Okay. And look ahead. Why don't we take a look at the semester calendar very quickly, just to know what's going to happen. There will be some very slight change on the release of lab number 3, which I'll explain to you. All right, so we are now right after the reading week. We are now here, lecture number 10. And don't forget, we'll get all the way to lecture number 24 at some point, right? But we'll get there, one lecture at a time. So for this Friday, your lab number 2 will be due. And for lab number 3, that one is meant to be about composition and aggregation. But I don't think we can really get there until maybe next Monday. So I would suggest for lab number 3, we're going to delay that maybe for 1 week. But you still get enough time to complete it, so don't worry. Okay. So for this week, you definitely want to catch up with the lecture if you haven't done so, and also make sure you finish lab number 2 properly. But of course, submit your best effort by the submission deadline just to claim the credit. Looking ahead, for this week and next week, we don't have any assessment, which is good. You can catch up and then visit me or the TA for questions. And for tomorrow, the scheduled live session, I will be there to help you on the lab 2 if you got any issue. And your written test number 2, for your information, that one is going to be November 1st, in about 2 weeks' time, right? So you may just want to get started with studying, okay? I'll talk to you a little bit more about it. I'll also give you a practice question, as usual. And your programming test number 2 is also coming the week after, right? Just make sure. You got 2 weeks from now to really get ready, right? All right, very good. Do you guys got any question for me before I move on? Good, very good. Okay, today, I think for the very big part, I would think it might be useful to actually kind of, not really review, but talk about something very relevant to what we spoke about right before the reading week, about a Wednesday before the reading week. Let me just give you 1 or 2 minutes recap about what we said on the Wednesday lecture before the reading week. And today, we're going to follow up with it before we get to object equality, which you definitely want to get into as well. All right, so if you go back to the notes, let me just give you some recap. I wouldn't just go into the detail. The recording has been up there. You can definitely review them if necessary. So we basically talk about how you can test for exception. Sorry. So we talk about console tester, but don't be too obsessed about the fact that it's actually about system the outer print line. The corresponding JUnit test would just be the same, logic-wise. But today we're going to do some very careful comparison about, in some cases, the logic might just work in the JUnit test cases, but it wouldn't work on the console tester using system the outer print line. We'll see very closely today, okay? But what you should really review, if you haven't done so, so maybe starting from today, you want to review about the console tester version number 1. Especially for each console tester, I would suggest the following. Number 1, look at the definition for the tester. Number 2, when you try to trace the code for the tester, you want to trace for both scenarios. Scenario number 1, when the implementation under test is actually correct, in which case you wouldn't expect any exception to be thrown. Number 2, it'll be the opposite. The implementation supplied to you for testing actually turns out to be incorrect. In this case, the execution flow for your tester should be the abnormal one, meaning that the exception will be expected, right? So these are the 2 scenarios. Always keep in mind. And that will be also tested in the written test number 2. So just make sure you review that. I would say if that's really the first time you're seeing this kind of testing, it could be a little bit tricky and confusing to get right. So speak to me. You still got 2 weeks. Right, console test number 1 and also console test number 2. Excuse me. And also, we got the exercise over here. And this one here, we're going to revisit this example, but from a slightly different angle today. We're going to compare this one here without nesting the try and catch block. What we explained on the Wednesday before the reading week was this one logically is incorrect. Right? Why? You can look back to the lecture to see why. But today, we're going to revisit this to say, what if we try to replace every occurrence of, for example, the print line? I'll give you one example. I'm going to see the exact detail in just a moment. Here you can see print line, and also print line. What if we replace the occurrence of print line by the corresponding JUnit assertion? Is it going to work? In this case, print line will not work. It turns out if you replace them by assertion, they will work, interestingly. But we're going to see that today in detail. That one I will definitely discuss with you and make sure you are okay. Right, so that's the exercise you should really review. And also, we got some interesting, nice case study about iterative tester. You can also review that. And that's basically the last two examples we did, but we're going to revisit them again. That is to say, if you compare, for example, you got console tester number 1, you can see every occurrence of the print line, they have been replaced by the corresponding assert equals, fail, and also do nothing. Right? So that's kind of correspondence we talk about. All right? I'll revisit that today again. Right? We talk about, just one example. Sorry, beg your pardon, just one. And we're going to see other example today. That's kind of a very quick recap about what we did on the Wednesday. If that seems very strange to you, time to review. All right? Alrighty. And let's now start with something a little bit more kind of useful beyond the course, not necessarily directly relevant to the course, but I thought it would be nice to talk about it. Okay, let's take a look at this. So I think, just for your information, we discussed up to and including slide number 21 before the reading week, so that's why we start with 22. We already talked about certain test cases. We only talk about console tested 1 and 2 different scenarios. And now the question is, only running 2 test cases, can they ensure your implementation is actually correct? Would it be enough? Intuitively, definitely no. Right? I would say usually if you're testing some very realistic application, you need a large number of test cases. Even for counter like this, we can even argue just testing for 2 scenarios is not enough. Okay? That's a conclusion. I can tell you right away. And what I want to show you now is something called derivation of the test cases, give you some idea. If you want to derive your own test cases, either in this course or in the future, that would be one strategy you can consider. This is not really directly relevant to this course because testing is a very big topic, so I can only just give you some idea about how things can be done in the simple cases. But since you guys might be in the engineering major, you can also take 4313, software engineering testing course in the 4th year if you're interested. All right? So what I would want to do now is to talk about some general strategy of deriving test cases. Okay? And let's just recall the context information we have. We have the minimum value for the counter, in this case, just 0. It could be any minimum. We also got some maximum value of the counter, which will be 3. Okay? And just by looking at the boundary information, we will be able to work out to really test the implementation exhaustively how many test cases we will need. It turns out 2 is far from enough. So that's why I want to give you some idea. And what I'm putting here is something called state diagram. Or you can say state transition diagram. If you're in the engineering major, unfortunately, you wouldn't really learn about this in an EECS course. It's usually covered in EECS 2001. But somehow they decided to remove it from your requirements. But that's OK. Don't worry. So I'm going to give you some very intuitive introduction. It's very straightforward. All right, so let's talk about this. Since we know the counter value is going to be in between this and this inclusively, so what are the possible values between 0 and 3? Well, just list them out. 0, 1, 2, and 3. So these are the so-called 4 possible states of the counter. Right? So whenever you want to derive some test cases, consider what are the possible states for your attributes or variable. So we got 4 possible states. So that's the key terms to notice, all right? And initially, the initial states is when the counter value is simply 0. And the maximum value will be the state where it is 3. And now we want to know how we can go from one state to another. That will be the idea, okay? And in this case, it's very straightforward. If you recall, what are the mutators for the counter class? Increment or decrement, right? In each state, we should be able to try to either do increment or decrements. Of course, the expected outcome will be different, right? So in this state, we can do either increment or decrement. In this state, we can do either increment or decrement. Conceptually, we can already work out how many test cases we need in total. There are two possible operations we can do, increment or decrement. There are also two here, and two here. We got 8 test cases. But what are they? Okay, let me take a look. So let's say in the initial states, if I want to do increments, that will simply go from 0 to 1, the counter value. What about I try to do decrements? Should I go from one state to another? Not really, because I'm expecting some exception, right? So if I try to do decrements over here, what I would expect to see is a value too small exception. So that is why if you try to write a test case for this particular transition, I want to initialize the counter, do increments, the expected value should be 1. And in this case, I don't expect any exception to be thrown. Second scenario, if I say I have the initial value 0, and I try to do decrements. In this case, there will be no expected value for the counter because I'm expecting some exception to be thrown, disrupting the execution flow. Right? So you can see each test case will be different. I think a diagram would definitely help. Let's complete the state diagram, and then I'll make some remark, and then we're done for this discussion. We can go from 1 to 2, also by increments. We can go from 2 to 3, also by increments. Can we do any further increments? Not really. If we try to do another increment over here, we will be expecting some exception, which will be value too large exception. Okay? And what about the other direction? If, let's say, we are now in this maximum value here, we can definitely do decrements, in which case we will go from 3 to 2. Do another decrement here, 2 to 1. Another decrement here, that will be 1 to 0. And just to be consistent with the color, I might just want to make this green. All right? And in total, how many test cases do we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 test cases. So for this simple counter example, even, we need 8 test cases to be thorough. And of course, we only discussed some of them. And some exercise beyond the lecture is for you to maybe have some JUnit test class extended with all the 8 test cases. All right, that will be some optional exercise for you. Do you guys have any questions so far? Just about this simple example. And of course, in real life, I can tell you where the complication might be. Number one, you don't always have just one single counter value or single attributes to worry about. Usually, you will have a combination of different attributes. And it will result in something called combinatorial explosion, meaning that the combinatorial possibilities for all the attributes together is simply way too many. So that's why in reality, you simply just cannot test every combination. It will be almost infinite. So what can you do? Well, you will have to take a software testing course. They will actually give you some idea about how you can reduce the number of test cases. For those of you who might be interested, I can suggest some keyword you can look up, or you can just speak with me if you're interested. So there is a very common strategy called equivalent classes. For those of you who might be interested, you can look it up, and then can take a look at a Wikipedia or maybe some paper or introduction on the web, and then you can discuss with me if you're interested. But again, for 2030, we don't really ask you to really write JUnit test cases. We only give you test cases and expect you to really read it and derive the implementation. That's all we do in 2030. All right? But maybe good for your knowledge. Maybe later you will attend some interview for software developer. They might ask you to derive test cases in the interview. So this might be some nice extra study you can do. All right, let me go back. Right, so we got 8 test cases, exactly what I just illustrated. You can also use a table rather than state diagram. That's fine too. So 8 test cases, and we got 6 more, okay? All right, so what we want to now do today, rather than using console tester, if you kind of recall how I illustrated console tester in the Eclipse before the reading week, what I had to do is I gotta launch the application, look at what's really on the console with my eyes, and check to see if the output is really what I'm expecting. That's manual, that's too error prone. If you got a large number of test cases, it's simply not going to scale. So that's why a much better solution is what I have you guys do since day 1 in the lab 0, which is JUnit test, right? Just remember this part here, when you study the slides, this paragraph over here is very crucial. It kind of explains why we wouldn't just do system.out.print line to do software testing. It wouldn't scale, it's manual, it's error prone. So what we want to do from the next slide, JUnit test. But in the written test, to be more practical for you, in the written test, you ought to know when you got console tester and when you got JUnit tester, how can you combine, how can you compare how they can be traced? That's something you should know. All right, but in practice, only use JUnit test as much as you can. All right, let's now do the transition to JUnits. And let me just see the next slide I should look at. Okay, good. All right, so for the JUnits, we just want to automate the testing. And about this automation sentence over here, at the end of this lecture, I will explain a very useful idea called regression testing. For those of you who really want to explore how you can do testing systematically, you really want to follow through the idea about regression testing, I will have a flow chart to actually show to you, go over with you, make sure you're okay before we depart from the lecture. Please just bear with me at the end of today. All right, good. And guys, just for this one over here, right, there's something also what I explained last time, right? Just very quick recap, very quick recap without reading off the slides. Just remember, whenever you want to do test, think about what's really the expected outcome. Is the expected outcome some normal return value from the method? Or is the expected outcome some thrown exception, right? It could be either. Usually not both. Never both, actually. Just remember. Okay, so for this part, you can definitely just go through. And this is exactly what we did in lab number 0, right? Just for your reference, just in case you forgot about the details. So we don't need to be bothered by this. And this is something interesting. If you try to create a new test class in JUnits, this is what you typically will get. They will give you a default test. Oh, by the way, something which I found together with your classmate when they came to my office hour, you might sometimes forget to put this test tag. If you forgot about it, that method will not be treated as a JUnit test. Okay, just be careful, right? And this will be the default test case that will be provided by JUnits. And that one there is simply using the fail assertion, which we talked about before the reading week. Fail simply means fail the current test without even continuing. So if you want to compare this with if you simply say system.out.print line. And then if you simply say error over here, they are very different. In this case, the execution flow can still continue without being disrupted, without any exception. In this case, the assertion will fail, everything will be disrupted. You just end over there. Okay, just remember. And there will be some interesting case study either here or maybe later to look at. So for this one here, the main thing to remember is execution flow, not disrupted. Not disrupted. On the other hand, the fail assertion over here will disrupt the execution flow. A very simple question, or a very trivial question is, let's say I got this test over here. It's simply going to fail by default. How can I make the test pass trivially? Well, remember what we said before the week. In order for a single JUnit test to pass, as long as it does not throw any exception, or it does not have any assertion failure, then it will be considered as a pass. But now we got some assertion failure. How can we just make it pass? Well, just get rid of it, right? Yeah. If that's what you're thinking, then you're right. Let me just remind you a very important principle, and then we can move on. For a test to fail, either exception or assertion failure. And you will see the more detail also on the slides, which I can show to you where they are. Assertion failure. All right, just remember this principle, okay? And the typical exception, I can tell you. And you might have experienced that already. Null pointer exception. Null pointer exception, and also array index out of bounds exception. So these are the two very typical ones. For these two exceptions, usually they are related to some logical errors in your code, right? So that's something you want to watch out for. All right, let me go back here. Let's see. Yeah, exactly over here. So we say a test will fail if either assertion failure or unexpected exception. So these are the two, what I just mentioned, okay? All right. And just to check, do you guys know when, let me put it this way. Do you know the difference between null pointer exception versus array index out of bound exception? What kind of condition can trigger each? Do you guys know? That's somehow implicitly also covered in the review lecture. Also, it was tested in the written test one. I just want to make sure you guys are okay with these two exceptions. Can anybody just give me some very informal explanation? When will you get null pointer exception? And when will you get array index out of bound exception? Yes, please. Okay, sorry, can you say that again? Null pointer exception first. Null object, okay, you mean the context object being null. Yes, that's good. How about number two? Array index out of bound exception. Yeah, or maybe -1, right? Either too small or too large. Awesome. Okay, let me make it a little bit more formal. All right, it's really important, so that's why it will be worth making that explicit now. So these are the very common exceptions, and don't get me wrong, these two exceptions, oh, I should really switch to iPad first. I forgot. Even though these two exceptions are very easy to understand, but even for advanced programmer, they run into these exceptions. Don't feel bad if you run into them, right? But you need to understand, okay? Start with, let's say, null pointer exception. Null pointer exception. This is how I remember it. Think about you have some method call, something dot, some method, and over here. This part over here is not relevant. Null pointer exception does not come from the right-hand side of the dot. This part here is not relevant. And this part over here is the context objects. Oops, sorry. The context objects. And when the context object is simply just equal to null, this is how you get null pointer exception. Let me just say two more things. A typical one could be, let's say if I say some object obj dot some method. In this case, if obj happen to be null, of course you get null pointer exception. But I can tell you that the more common scenario is like this. You might have obj1 dot some attribute 1 dot some attribute 2, and then dot some method. You might run into null pointer exception in such cases, okay? And there are many possibilities how null pointer exception can occur. It could be that this context object over here is null. Possibility number 1. Or object number 1 is not null. However, object 1 dot attribute 1 turns out to be null. Possibility number 2. Number 3, you can kind of see the pattern. Number 3 would be object 1 is not null. Object 1 dot attribute 1 is not null. But object 1 dot attribute 1 dot attribute 2 is actually null. That's possibility number 3. All right, so we got 3 possible scenarios where you can run into null pointer exception, right? That's a conceptual. Number 3, number 2, and also number 1. All right, are we good about null pointer exception? Right? And let's talk about index out of bound exception also. So the second exception we can talk about is index out of bound exception. And actually, this one here, I can also review very quickly about the logical operator in Java. Okay? Index out of bounds exception. And let's say this. If we got an array, okay, of any type, and then we try to put in some value. And you can think about this value over here can be any expression, any integer expression. For example, it could be maybe just I. That's very typical. I could be a loop counter. Or it could be you somehow put I minus 1 or I plus 1. That's also very common when you write a loop. Okay? Doesn't matter. Just any integer expression. And it occurs. The index out of bound exception occurs if, okay? There are different ways to phrase this. Okay, let me give you 2 possibilities. Number 1, either when it is too small, the index, or when the index is too large. When it is too small, you can say the v here is strictly less than 0. The smallest index is always 0. All right? Either that, or the value over here is larger than or equal to a.length. Okay, let me just concretize that a little bit. Let's say A is simply an array over here, right? Let's say it's from 0 all the way up to, let's say, 9. So the length is actually 10, right? So when I say larger than or equal to equal, it's also considered as error condition because there's no such index that's equal to the length of the array, right? That's one way to phrase it. And a little exercise for you, which, if you want to know the answer, speak to me. Otherwise, I assume you're okay. I can ask you in the test. All right? Think about it. What if changing this to, would that correctly characterize the error condition? Yes or no, and justify. All right, that's your exercise. All right, so this is one way to talk about how we can get the index out of bound exception. There's another way to do it, okay? I can say number 2. It is not the case that the index is actually valid, right? You can see I put an exclamation mark, I put a parenthesis, that means something got to go in. So what goes into the parenthesis would be the valid condition for the index, which would be, you can say 0 less than or equal to v, and also v strictly less than a.length. And of course, the exclamation mark is really important. And I got a similar exercise for you. What if I change this to the OR operator? Is it correct or incorrect? And justify. All right? You got two exercises over here. Give it a try and feel free to me. I think it's something I kind of assume you have seen in the first year, but it's definitely important to catch up in case you haven't. All right? Think about it. All right, so that's about some very nice review about the two kinds of exception. Let's move on. Okay, right. And this part here, we definitely have done already. So green bar, okay. And then that's, again, about the different assertions over here. Let me see if I got anything missing. Give me a moment. Okay. So we got different assertions here. We got assert null, assert equals. Okay. We don't really use assert array equals much in this course, but it does exist in the JUnit library package. So for those of you who might be interested, you can feel free to go to look it up. We don't really use it for this course. I think what you will see we use in this course will be assert null, assert equals, assert true, assert false. That's something you will see more often, okay? And assert true and also fail. And why don't we do some very simple example, right? I'll just do some of them. You can definitely continue with the rest. It's somehow already mentioned in the lab 0. So let's just do a few. Let's say this. We got the point class. We got x and y. We got a constructor here. We got very simple accessor, get x and get y. All right? Guys, you tell me. First of all, we declare some reference variable p. Assert null, true or false? True, false? True, agree? Because if you only declare some variable without initializing it, it will store its default value. For reference variable, just null, right? I'm pretty sure you know. Okay, this one's easy. And we can try to write equivalence but different assertion. We can say it is true, p stores null. It is not true that p is not equal to null. It sounds a little bit tricky, but it's also right? All right, so this one will actually fail. Oh, for this one here, let me say it again to be more precise. If you think about at this point over here, p is actually null. And then if you say null not equal to null, that should be false. In that case, you know what? I think this one here should be true, I think. Let me just double check. At this point, p is actually equal to null. And you say null is not equal to null, which is false. That's exactly what we're asserting. So that should be check mark. All right? Yeah, I'm going to fix that typo on the slides. Okay. Are we okay so far? And what if we try to do this guy over here? That would be the last one I would like to do with you. Any idea? Are we going to get assertion failure or something else? Be very careful when you run this assertion. Let me give you a little bit hints. In order for you to evaluate this assertion over here, you got to do three things. Number one, you got to see what the expected value is. In this case, easy evaluation is simply 3. And then you got to evaluate the actual value, and then you got to compare them, right? And then to see if they are equal. What's going to happen in this case? Given what we have done so far. Are we going to get assertion failure? Or please? What kind of exception? Null pointer exception, I agree, but why? Yes. Yes, that's exactly right. Yep. Thank you. That's exactly what we're going to see. Null pointer exception. Very good. All right, guys, that's exactly the one example for what we just spoke about, right? About null pointer exception. All right? And for the rest of these, I will assign them to you as exercises. you've also got the answer on the slides. And I'll make sure I change this, fix it, all right? And one more thing about JUnit assertion, right? And this one, I think we also spoke about it in the left 0. That one just to make sure, whenever you're trying to do assert equals, again, it's a very terrible typo, again, from my side. That should be assert equals. I'll change it. Okay, assert equals. And we got expected value here. We got actual value. And we also got this. And we explained it before, it's tolerance, right? Because the decimal number cannot be represented faithfully in binary system in the computer. So that's why you got to give some tolerance. Okay? And of course, there will be passing for this case. Just remember, this is about tolerance. All right? And let me see what else. Okay. That'll be the second example, which is about tolerance, right? Everything has been explained, so just make sure you also study the slide just to be precise. And so these are just more examples. I just got this table somewhere from the web, just summarize the assertions. But I would say as long as you understand how we use the assertions so far, it should be fine. And sorry, the font is a little bit small, but you can see this entry over here, this part over here. We got something called assert same, assert not same. That's something we'll see more when we get to the object equality lecture. So you will also learn about them too. All right, we'll get there. Okay, yep. Before I talk about this, why don't we take attendance? All right, you guys want to get ready? Right, let me start the course. Yeah, usually it will be much more difficult to really stick to coming to the class after the reading week. Just hang on, right? It would be nice to see you guys every week or every class. All right, let me start the class over here. And then you know what? Just choose an option there, right? We don't need a question there. Yeah, if you got any trouble, please raise your hand right away. Yeah, I'll wait for maybe another 30 seconds. All right, just make sure everybody does it. So once I close it, done deal. Any issue so far? Everybody's okay, right? I assume. Okay, I'll wait for just another 10 seconds, just to be sure. All right. All right, I'm going to close it. Okay, thank you so much. And I would suggest, don't go away. I think, why don't we take a 2-minute break? And then we're going to go back to the JUnit test example, the tester. That one is going to require your brain power. Take 2 minutes. Actually, we just finished taking the attendance. I'll take you this time. Yeah, find your name and sign. Yeah, earlier next time, please. All right, no worries. Yeah. Thank you. Yeah, no problem. Okay, 1 more minute, and then we should really resume. All right. All right. All right, why don't we get started again? All right, so for this part here, I would like to go back to comparing two kinds of tests. One test is implemented in console tester fashion with system out of print line, which we did before the reading week. And the other one to compare against will be something like what you see on the slides, which is by using assertions. We're going to compare them side by side. Okay? For the first one here, just as a warm-up. Okay? This one here, let me see. Okay. Similar walkthrough as before. Okay? So I can do a little bit faster since you understand logic already. Let's say you got the same test. So this one here and this one here are the same. So the same JUnit test will only be considered as good if it can go for one execution flow to say everything. Oh, let me put it better. The same JUnit test would be considered as good if the following. Number one, if the method that we are trying to test was implemented correctly, you should go for the corresponding execution path. One thing. Number two, if the increment that we are testing somehow happened to be incorrect, it should be another execution path. You might sound this familiar, right? That's because we talk about this in the context of console tester, the same argument. We're not doing something very new. What you want to notice is, so here, rather than saying system the out of print line, we just say assert equals, and also fail. All right? Let's go a little bit deeper over here. Okay, let me see. Okay, let me just do this. Let's talk about scenario number one. Let's say the increments was implemented correctly. What's going to happen is the execution path will be, let's try to highlight it. We initialize the counter, and then we try to make sure the initial value is correct, just using assert equals. And notice that we don't have any tolerance specified because it's integer. We only do tolerance for double value, floating point. And we try to do theta increment over here, right? Since we assume, let's say the increment happened to be correct. Okay, so in this case, no exception thrown. In that case, we can definitely move on to the next line. And after that, we will just go to beyond the try and catch block. That's the execution flow. That's one scenario where the test does its job. That's one thing. The other thing, what if the implementer gave you something that's wrong? You, as a tester, you should report the error using the same test. Let's see. So now we are talking about the test over here was implemented incorrectly. Okay? And of course, you can think about this kind of incorrect implementation. We talked about it in the Wednesday lecture before the reading week. So let's not repeat. Okay? And let's see the execution flow. You will still initialize the counter, and initial value is OK. And then we do the try block, theta increment. Now, calling the increment method here, let's say this scenario is implemented incorrectly. It's going to throw some exception unexpectedly. Let me write it down. So let's say exception thrown unexpectedly. Unexpectedly. And then what's going to happen is it's going to break the execution flow and go to the corresponding catch block. And then we're just going to catch it, and then we're going to fail the test because something unexpected happened. All right? Are you guys OK with this? It's kind of like a repeating what we explained about the logic, but now it's in a different context in JUnit test. All right? The same test can do two things. When the implementation is correct, confirm it. When the implementation is incorrect, report the error. Always keep that in mind, the principle. All right, and then let me talk about this one. Let's see, decrement from, OK. This one just another flavor, OK? It's a different example, by the way. Let's take a look. So here it's called test to decrement from the minimum value. And how do we visualize this, by the way? Decrement from minimum value. If you recall the state diagram we just drew, to decrement from the minimum value, that's what we're doing. We're expecting some exception, specifically value too small exception. Okay, just remember. And for that one there, let me just show to you the correspondence very quickly. You can see here, we got assert equals. And here we got assistant out the print line in the console tester. Over here, we got fail. Over here, we got print line with error. And I just explained it. These two are not exactly the same. One is going to break the execution flow. The other one is not. All right? And then we got catch. Here, things will just work out. Right? So that's why we just let this test do nothing and then pass the test. And this one here to print out success. Right? That's kind of the one-to-one correspondence. Both work, both. And let me see if there's anything else I want to say. Let me just do one example here. 2, just for completeness. Scenario number 1. Let's say the decrements we are testing, decrements implemented correctly. Okay, let's take a look at the execution flow very quickly. So we're going to execute this line over here, and then we're going to execute this line over here, and then execute this line. If it was implemented if it was implemented correctly, what will be the correct implementation? Correct implementation should be the decrements, when you try to do it, when the counter is in the minimum, it should throw some value to small exception as expected, right? So here we say it will throw the value to small exception as expected. That's something we assume for this scenario. That way, we're going to bypass. That means we're not going to fail, right? We wouldn't go to the next line. And then we're also going to bypass the catch as well. So we just go to the next one. That'll be scenario number 1, okay? For completeness, let's do scenario number 2 very quickly, right? And one more thing to say before I go to scenario number 2. If you compare this one over here, let me be very precise about the point I'm trying to make. Let me open a new page. Bear with me. This is one here. And this is the one we're talking about. Oh, let me get rid of this. All right. If you compare these two tests, looks very confusing. Because you can see in one case, after the method call, we got assert equals. In the other case, after the method call, we got fail. In one case, the catch block got fail. In the other case, in the catch block, we do nothing. If you have already understood the logic, that's the way it should be. So it's not that confusing. Let me just recap on this part here, and then I'll go back to scenario number 2. Okay, so here, what you want to really make sure you convince yourself. This is to say, reaching this line means no exception happened unexpectedly. All right, and for this one here, the value to big exception happened unexpectedly. That's why we got to fail the test. All right, that's how you interpret these two lines. All right, let's take a look at the second one. The second one here would be, if you reach this line, what does that mean? That means some exception actually did not happen as expected. That's why you got to fail the test. The expected exception did not occur. And for the other scenario, the expected exception did occur. That's why we can pass the test without doing anything. All right? The expected exception occurred, in which case pass. All right? All right, this is a very important comparison, which was not in the slides. So just make sure you understand about these two. All right? And for scenario number 2, let's go back to this test, will be if the decrement's not implemented correctly. All right, just for completeness, let's make sure we mark the execution flow, right? We're still going to initialize the counter. We're still going to check its initial value, so far the same as before. And when we try to call the decrement over here, in this case, decrement was not implemented correctly. That means it's going to throw some exception unexpectedly. In that way, we're going to fail. And once we fail, we're going to go to catch. Right? Oh, actually, sorry, let me say it again. Once we fail, the execution flow will be disrupted. We fail the test right away. You don't get to go to the catch, by the way. You don't. Definitely not. All right? Guys, are we okay so far? Okay. Just make sure review everything also by yourself, and then just confirm. All right? All right, so I think for the second one over here, now we should do some important comparison. This will be the most challenging example for today, all right? And we'll do that reasonably, not in a rush. Okay, that's something we have seen. And this one here, okay? Let me see, yes, okay. I want you to, first of all, spend 1 minute. This is the console tester number 2 we did before the reading week. Why don't you take just 1 minute, go over this, and just make sure you kind of recall what happened very quickly. And of course, the main thing to remember is we got nested try and catch block. All right, and then we'll see something new. If you kind of forgot about the logic behind, maybe it's time to maybe study the recording a bit, right? This part is really important, all right? Oh, you guys are too shy. I really meant you to look at this one on my iPad. I forgot to switch, all right? You guys are half awake, right? Kind of, maybe, all right. This one here, okay, take 1 minute, please. Take a look at this, all right? Console tester too. Nested try and catch. That's the one we should look at. All right. All right. So you can see that's the outer one. That's the inner one. And also, we are only using print line. Okay. What we said before the reading week, 2 things. Number 1, this works. Why it works? You can go back to the recording. Number 2, what if we try to unnest the try and catch block? Would it work? The answer is no, it will not work. Why? You can go back to the recording and look at what we saw, what we discussed on the Wednesday. Okay? Let me remind you very quickly. Okay? If you go back to the slide, this is what you can do. Something hopefully you have noticed. If you look at this slide, slide number 42, right, you will see there are 2 links over here, 1 and 2. All right? And when you get to the slide 42, the one you're seeing over here, which I mistakenly asked you to look at first, this one is the working JUnit version. If you want to look at the one we looked at before the reading week, click on this link. And then you will see the console tester too. All right, look at this one. And then you can just go back to where we were, which is over here. And there is a second link, which I want to discuss now. The second link is when we got the alternative. Let's say we are still using the console tester, but we try to unnest the try and catch block. We explained it before the reading week why this wouldn't work. Okay, the structure over here. You simply try and catch, followed by another try and catch. So now here is a question that's new. What if we replace the print line over here just by assertions using JUnits? Is this unnested structure going to work or not? All right?
Yeah.
You think that will work? Why?
Because the reason this wouldn't work is after, let's say the first line, the first print line works, we print an error to the value to null, right? Then we would actually still go to the next try.
Yes.
And if we can increment, we can go also print success.
Yes.
But with the assertions, if it fails, the first one, then we interrupt it. We stop.
We just fell right away. Exactly. Awesome. That's very spot on. All right, guys, let me wave the hands a little bit from your name? Says? Fels. Oh, okay. I'll get it right. Okay. Anyway, let me just hand wave a little bit, and then I will make it precise. It's really important for you to see. This console tester version wouldn't work because, let's say, if something that goes wrong, the exception was thrown prematurely from here, you would just go to the catch block. And then you can still continue from the second try and catch block, which was unnested. You can still get the message success, which is contradictory. However, if we replace the print line over here, let's say increments, somehow by some assertion failure to say, if you actually, oh, sorry, the assertion failure over here, to say fail. If you actually got the premature exception thrown, you want to fail the test right away without even continuing to the next try and catch block. That'll be the idea. Right, let's take a look. It's really important. Okay, let's take a look. And when you look at the notes later today, so this is just to compare these two, right? Let me just make a note, and then we'll look at that one. So this one is working. This one over here is also working, right? You can see this one here is nested, try and catch block, and this one is unnested, which means nested console tester works. JUnit test, even though it's unnested, still works. Right? Let's now take a look at this one over here. Right? This one here, it will be something like this. Console tester, that's the exercise I just showed to you. Right? You can see this part over here is unnested. Unnested. Not working. And this one here is the JUnit test version. This one is also unnested. But interestingly, it will work. And the key thing to look at right now is like this. Let's say this. Let's say we have C dot increments over here. All right? If some value too large exception thrown unexpectedly. In that case, we're going to go to the catch block and then fail. And this part over here is going to guarantee once the fail is executed, we are not even bothered for the rest of the test. We just fail that right away. That's a big, huge difference. All right? And from this one over here, the test fails right away. On the other hand, if you go back to the console tester over here, if you say, let's say, C dot increments, we got similar kind of error. Let's say the value too large exception thrown unexpectedly. Okay? Thrown unexpectedly. And of course, we're going to bypass this. We're going to the catch block, and we're going to print out the error. So far, it's the same behavior, so far. However, it's only a print line. It's not going to disrupt the flow. That means it will still continue to this try and catch block, which is now right. Because you got the possibility, after printing error, you also print success. That's not right. All right, just remember, that's what we explained before the reading week. All right, let me just make one more note, and then I'll see if you got any question on it. Okay, so after this, the flow not disrupted. I would say this might be the most sophisticated comparison you have to make just for this one here, for this example. All right? Guys, any question about this? Yes, Abby. Yeah.
And then inside the class, we just put like an exit statement, would it work?
Oh, exit statement.
Because then it's like, well, it's like, I don't know, then you would just exit the code if you get to that.
Yeah, that one might be okay. Yeah, that one I haven't really tried. It might be fine, but I wouldn't test you on that, don't worry, to actually try to exit. However, even if you put an exit, let's say, in place of the print out the error, okay, so Abby's question was like this. Let me make it clear. What if, let's say, in place of printing out the error, we simply say exit. Somehow you can just make sure you exit from the code. It might work just to, as far as breaking the flow is concerned. However, the approach still remains to be manual, which means you still got to see from the console whether or not the program exit abnormally. It's still no comparison to automated version, like in JUnit test. So even though it might work for this for exiting early, but we wouldn't adopt it. Yeah, good question. Guys, any more question to follow up before I leave you with this? Everybody's good? Okay, very good. Okay, so I think we got one more to ask you about. Okay? Let's say this. We are so annoyed by so many try and catch block. Can I just combine two of them into one? Can we or can we not? So let's say we're still doing the same. Let's say we want to increments 1, 2, and 3. So this will make sure we go from 0 to 1, 1 to 2, and 2 to 3, right? And then when it is actually 3, which are the increment, and we want to make sure at this point the exception must be thrown so that we can catch it. Otherwise, if after calling this increment over here, if we didn't throw that exception as expected, we're going to fail. Can this work? I'll give you guys for 1 minute to think about. So the difference is we are still using JUnit tests, yes, but we are not even talking about nested or unnested try and catch block because there's only one. Is it going to work? Okay, just hold that thought, please. Yeah, I'll just give everybody 1 minute to think about. Well, of course, the hints there says a lot in case you actually read it, all right? Yeah, go ahead, please.
I think it would work, but then if the value to large exception is thrown unexpectedly, then it wouldn't show that.
Yeah, actually, you're saying that. Yeah, actually, your initial remark was actually wrong, but what you said later was actually right, right? So since you're pretty much spot on that. Okay, let me just get there. Okay, the answer is this would not work. Negative, because it is true. First of all, if the exception is actually thrown from here, that is okay. If the value to large exception thrown, it is expected. That's why if it wasn't thrown, we just fail, right? But the similar argument can be applied to the previous increment. Let's take a look. Right, we also got increment here, right, in the same try and catch block. If the value to large exception thrown, in this case, are they expected or not? No, right? Unexpected. That's a big problem because this catch block over here is only to say I want to catch value to large exception. I'm not distinguishing which line in the try block is going to throw it. It can be from here, in which case it should fail. It could be from here, in which case it should pass. Contradictory, so we don't know. That's why a single try and catch block wouldn't work. All right? That's a very quick explanation for you guys. Okay, this one is to say, it's not possible to know whether or not the value to large exception is expected or not. It can be either from here or from here. We simply don't know. All right, so that's why a single try and catch block wouldn't work. All right, let me just see. So that will bring us all the way to 45. All right. All right. Guys, everything has been discussed, so I just want to make sure you're okay. Yeah. Let me get to that slide. We just got a few more to finish. We'll see if we got any time to talk about equality. If no, we'll definitely start you fresh about equality on Wednesday. I want to make sure I finish this lecture at least properly. Sorry. Yeah, so this is the one we just talked about, slide 45, right? And then, this one's nice. Let's talk about it. Okay. This one here actually shows to you if you want to try writing your own test cases. Okay, here's the rationale for writing in style like this. Typically, the test case you have seen so far, we only test for one single value. Maybe you want to test to see, we want to maybe increments, or we want to decrement just for once or twice, not many times. Is it possible to try to test a more complicated scenario, right? To say, I want to increment all the way to maximum, increment all the way down to minimum, and then to do everything in one single test without writing so many calls to the increment or decrement. There's a way to do it. I'll show it to you. All right? The logic there is actually pretty simple. So I'll go over with you, highlight some important stuff, and then you can actually try to adopt if you want to write your own test cases. Okay, let's take a look. So we start with the counter, all right, the C. And then the try and catch block. You can see the single try and catch. Try and catch. We are catching either value too large or value too small, either way. Okay? And now inside the try block, we got 2 for loops. You can think about the reason that we're using for loop is because we want to replace several calls to the same method by just a loop. So we can use the loop counter to automate it. Basically, that's what we're doing. Okay, let's see. We say from the loop counter starting from initial value, the minimum value, all the way to the maximum value minus 1, because that's really the largest value. You can still do increments. And then we're just going to keep calling increments. And we want to make sure if there was any exception thrown from any of the increment over here, it's going to be caught from the value to large exception, and then we fail. Right? That's the kind of the intent. Any unexpected value to large exception thrown here will fail the test. Because you can see it will just be connected to exactly this catch block over here. And if no, we can simply make sure the value is as expected. Right? That's the increment direction. We can also do the opposite direction as well, because we know we can start from the maximum value here and then just keep calling decrements. If any of the decrements actually throw the value to small exception, that would be unexpected, so we can also fail. Right? Just imagine if you didn't have the for loop, what would you have to write? You have to write several instances of the call, in which case, still work, but just not as pleasant. Let's say if the question for you, what if the minimum value is still 0, but the maximum value for the counter is 1,000? Then this particular loop version will definitely shine, because you don't want to write increment 1,000 times, right? Explicitly. Think about it, all right? So this one here is just about how you can use a loop inside your test. That's a nice case study for you to get through. All right, exercises. And so here, this basically is what we did on the Wednesday before the reading week. So whenever you want to test for different execution paths for the same test, try to modify the implementation to be wrong or change it to be correct. You will explore different execution paths. That's basically what you have to do. So in the written test number 2, what you will be given, maybe a tester and maybe some implementation. And then we simply want you to trace the code. That could be one way to see which execution path you will go through. Another way would be a little bit more abstract, something like if I give you the test, let's say either console tester or maybe JUnit test, and I would say now assume the implementation is correct. Which execution path should it go? And another scenario, assume the implementation was incorrect. In that way, which execution path should we go? That's everything we have talked about today, right? So when you study for the lecture, think about what I might ask you in the written test. That will help. Alrighty, guys, one more slide before I end the lecture. Do you guys got any question before I talk about TDD? Everybody's okay? All right. Yeah. We get about 7 minutes or so for today. We'll see. If I need to take 7 minutes to explain TDD, that's okay. We'll just start you fresh on Wednesday. Otherwise, we might just be able to do some intro for 1 or 2 minutes for object equality. Right? Either way. Okay, test-driven developments. And let's use a diagram to explain to you the idea. Okay? It's a very useful idea, which you practice all the time. Okay? What I want you to think about, you can use a counter example, or you can use any of the classes that we develop for your Lab 0, Lab 1, and Lab 2. They all apply. Okay? Basically, you start with this one here. This is starting point. Okay? This will be your Java classes. You can think about this will be what goes into the model package implementation. And of course, obviously, could be right, could be wrong. This is what you will hope for. If your implementation is right, you will hope that there's a green bar to confirm. On the other hand, if there's any error which you may or may not be aware of, you will hope that the test can also reveal the error by giving you a red bar. Right? Both are important. Okay? And somehow getting a green or red in this course kind of depends on what tests you're given, right, in the lab or in the programming test. So that one, you don't need to worry too much. Realistically, if you have to write the test cases for your development, you have to make sure the quality and also the coverage for the test should be good enough. Right? That's something we wouldn't really teach you in this course. You'll have to take another course on software testing. But as I said, the equivalent classes idea, you can look it up. That might give you some inspiration. So what I will do is, once you got the model implemented, you can now run the test cases, right? So here, so this, you can think about this will define the correctness of the implementation under test. And it's really important for you to know the following. Realistically, it's very difficult to claim that your piece of software, which contains thousands of lines, to be 100% correct. We can only say it's relatively correct with certain confidence. It's pretty much like in machine learning. When people tell you that with maybe 95% confidence, I predict this is what's going to happen in next season. They cannot say for sure it's going to happen, but statistically it's going to happen, most likely. So in our case, it's similar. Depending on the coverage and the quality of your test, you want to make sure it's good enough to give you either green or red, and you can have relatively high confidence about what it is showing to you. All right? Okay, so define what the correctness of implementation under test is, and then, of course, it is very important about coverage. And number 2 is about the quality. And the coverage over here, Normally, it means the more tests, the better. Usually, coverage, usually, okay? However, quality here is also very important because if you test for 1,000 tests, but they're basically testing the same method, or they're testing the same aspect about the method without testing the boundary cases, in that case, the quality may not be as high, right? That's kind of an intuition. But for your lab and programming test, usually we give you rather good quality test, starter and also the grading test. So they should be complete enough, okay? And now that we got implementation, we got test cases, we will have to run your implementation against the test. And what can happen? Of course, if you actually got some red bar, so that means you got to fix your implementation, for sure. If you got a green bar, it's a good sign, but you cannot necessarily be so satisfied always because it depends on how complete and how well the test cases have been derived. Just keep in mind in general. And I want to talk about one more scenario, okay? Let's say you're developing your lab 2, let's say. You pass all the grading tests. You pass all the starter and also all the grading tests, okay? And a month later, you decide to make one of the methods more efficient. Maybe you want to change the way you implement the array, or maybe you simply want to replace the array by array list. You want to make some change, some internal refactoring, okay? That's a very important scenario I want to talk to you about. What I talk about so far is about a very basic usage of JUnit test, but what I'm going to talk about now is the more realistic scenario, okay? Let's say we want to do some internal changes. And the more formal term is called refactoring. You want to do some refactoring of your software. I'm not talking about name changes, not really that. Maybe you want to change the way you implement certain methods. And it could be for efficiency. And it could be just for you change the way you design your software, right? Can be either way. Okay, now, let's say you have changed your software. Can you just leave the change the way they are? Or you have to make some assurance the changes wouldn't introduce any errors into your software. Should be the latter, right? How can you ensure? TDD tells you any changes you make, however subtle they might be, you have to run all the test cases right away to make sure you don't introduce any new errors into the test, into the software, all right? So now I'm going to say, after this, rerun all the tests to ensure there is no error introduced. I know I'm running over time. Give me 1 minute. I'll definitely finish. Sorry about that. Right? So you want to make sure rerun all the tests to make sure there's no new error introduced. And of course, if you actually, after modifying your classes, you got some red bar, in that way, of course, you get a fix. If you got a green bar over here, there might be something else you can do. It could be that the existing test cases did not cover the specific changes you have just made. In that way, you may have to also extend your test cases to make sure you get a green bar, right? So 2 things. Number 1 is, if you got a red bar right away on the existing test cases, of course, you're going to fix the bug. Number 2, you may also need to add new tests to cover the new. Sometimes changes, sometimes additions. It's a very abstract flow about how TDD should work. I'll encourage you to put that into practice. Right? That's really a very nice way to make sure whatever you develop is correct. Thank you so much for your patience. We're going to start you fresh on Wednesday about object equality. And then tomorrow, for schedule lab, it's optional. If you want to come, work on your lab to social with your colleagues, come, and then we'll help you with lab 2 or other things. Okay, you guys take care.